Hello and welcome to the WebEx posting number 3 for the Temple University 2014 NASA Lunabotics Mining Competition, Electrical Team Division. My name is John Morris and I will be taking you through what we've done so far and what we also plan to do. Today I will give a quick introduction of our team, go over our electrical team goals, our power system goals, overall progress and the next steps. Our team consists of 3 electrical engineering students and 1 faculty advisor. Mark Halberstadt is on the left-hand side. He is an electrical and computer engineering student and our team leader. He is also responsible for the autonomous systems and control systems. Eric Schisselbauer is also an electrical engineering and computer student. He is responsible for computer architecture, control systems, and autonomous systems. I'm on the right-hand side. I'm responsible for power electronics, power monitoring systems, and electrical circuit design and testing. And of course on the bottom is Dr. John Helferty. He is our faculty advisor. This is NASA's 5th annual robot mining competition. Basically we will be competing to build a robot to mine regolith and navigate terrain. This is a university level competition. This table shows some of the categories that the competition will award points on. Some of the categories include the robot mass, the mass of the mine regolith, the average bandwidth, reporting of the energy consumption, dust-tolerant design, and autonomous operation. Since I am in control of the power systems and design, I will be focusing on the robot mass, the reported energy consumed, and the dust tolerance design. Basically the reason why I will be focusing on the robot mass is because the power systems and the battery are a significant portion of the robot weight. The more I can reduce the power systems and current draw, the more I can reduce the components and the battery. The reported energy consumption also has to do with the efficiency of the components and the circuit designs we use. The dust tolerance design, the reason why I will have to worry about this is because some of our electrical systems and wires connectors will be exposed and need to have a high dust tolerance design to be awarded the points accordingly. Some of our electrical team goals include designing and building a power system, which is what I'll be focusing on, the control system, which I will also be focusing on along with Mark and Eric, and then the communication systems, which Mark and Eric will be focusing on. The complete autonomous functionality is something that Mark and Eric are currently working on. And then the increased power efficiency, as I mentioned earlier, is something I will have to be designing and testing in order to reduce the size and weight of the battery and other components on the robot. So far, our overall progress is as follows. The driver program is running on the Raspberry Pi, and the Raspberry Pi communication with our Arduino have been successful thanks to Mark and Eric. And finally, the buck converter has arrived, which is something that I just recently ordered. Basically, for those of you who don't know, the buck converter is basically a variable voltage / current regulator. The converter that I ordered basically has an input voltage it can accept between 7 to 35 volts, which is perfect because our onboard battery, which powers pretty much everything on the robot, is rated at about 24 plus volts. DC obviously, and so the Arduinos and the Raspberry Pi they require 5 volts. And the output voltage on the buck converter can go anywhere between 1.25 volts to 30 volts, also DC. So this is perfect, and plus it's they don't take very much. The Arduino and the Raspberry Pi don't draw very much current, so this current can go up to 3 amps on the buck converter. So we are pretty much set to go on testing on these systems. Some of the power system goals include reducing the power consumption, as I mentioned earlier, which basically includes electrical component efficiency and power regulation methods. Some of the component specs we need to look at if we're going to be reducing power. For an example, we don't want to use a relay. Let's say, for example, if we want to try and switch one part of the circuit to another, which we're going to have to do on this robot, We probably don't want to use relays. We could probably go with another form of switching, most likely solid state, to save on power. Another thing where we can save power, which I just mentioned earlier, is by getting a buck converter as opposed to a voltage regulator, because the buck converters you can control and regulate the current, whereas voltage regulators you usually cannot. The battery size reduction is a big portion. Once we get these electrical components and power regulations more efficient, then we can start reducing the size of the battery and the power consumption. Another thing is the power, the monitor power usage. We're actually going to have to find a way to record the power that's used in a way that is acceptable to the competition judges. We were able to get some of the simple power control systems implemented on a testing platform, and the trial runs were successful. We basically set some basic code into the Arduino and fed them into the motor controllers to power the motors, and everything worked 100%. So the basic testings have gone pretty smoothly so far. Some of my next steps will have to be replacing the motor controllers on the testing platform and implementing the new buck converter that I just discussed. Some of the next steps that Mark and Eric will be focusing on will be the communication systems. They're going to be developing the Python and Java code for moving streams of bits between the robot and the central command system. And of course, the control systems they're also going to be both working on. I will probably also be helping on some of this as they implement control for the serial communication motor controllers on the Raspberry Pi system. Alright, our schedule for this upcoming week will be to replace the motor controllers, research ways to further reduce the power consumption, and finally install and test the new buck converter that just arrived that I just discussed on the testing platform to work with the Raspberry Pi and Arduinos. If you have any questions, feel free to send me an email at morris@temple.edu. That's MORRIS @temple.edu. Thanks so much for watching, and we hope to see you next time.